Good afternoon. It's my pleasure to introduce our last speaker, Professor Feng, a research fellow at BIMSA. Professor Feng is a distinguished scholar in set theory and mathematical logic. He has made notable contributions to higher order infinite combinatorics, large cardinal theory, regularity properties of the reals, and inner model theory. He is also a passionate educator and the author of several influential books, including Introduction to Mathematical Logic, Introduction to Set Theory, and the Order and Number. Today, he will present a talk titled On a First Order Theory Approximating Theoretic Economics, which explores the application of axiomatic logic to foundational questions in economic theory. Please join me in welcoming Professor Feng.
Thank you. Thank you very much for the introduction. I believe that I'm at the right place, right time to give this talk because there's so many young talented brains in the audience. So I would say this is, in some sense, I would extend my invitation to a project that I've been working since 1901. You can count how many years. Basically, the idea is try to set up a system, try to understand the theory of economics using that central ideas of mathematical logic, methods, ideas. So in some sense, this really is applied mathematics. So I'm doing applications. But it's a very complicated, sophisticated system, and you find that's very fascinating, challenging area. So let me start with the basic metaphysics idea, what we are doing. So attempt to apply the axiomatic method of logic to understanding theoretical economics by establishing appropriate first-order language and abstracting appropriate access. The core of the program in such understanding is to provide an intrinsic analysis of value. We should attempt to develop such analysis by isolating certain sets of basic concepts and their relations. Interestingly, it involves several branches of basic sciences where laws are well established and ready to apply. Also, axiomatic theory of sets is a part of the development. In this talk, I shall explain an outline of the analysis I've been doing since 1991 when I got interested in the theory of values in economics. And I will explain to you a meta theory. Mainly this talk is low technicality. It's really, in some sense, the theory of metaphysics focusing on the theory of economics. And then I'll explain how, remember, from the logical point of view, every theory, in fact, has two parts. One is the metaphysical part, the basic theory you are working on. And then there's a subject or objective language or objective theory that's built up on the metaphysical language. You try to express what the ideas of your understanding. So that's the basic concepts of the objective language where we're going to use it. Basically try to understand our universe, the real reality. And then I will tell you a very simple part of the formal theory. Again, the slow technicality. But I will tell you it's able to formalize into a formal theory, and then we draw very simple conclusions. By looking at the conclusions, I believe you will find out, in a sense, it can be applied to interpret our reality or consistent with our intuition or what we are understanding. So I will tell basically the four parts. The major part is the first part, what's the meta theory. So basically, the presentation I'm giving here is very selective. It's not going to be complete. It's impossible to complete to give you a lecture in 15 minutes. And this really is, in some sense, taken from there's a very draft manuscript I've been working on more than 200 pages. Its title temporarily is called Complexity, Intelligence Effect, and the Value. The target is to define intrinsically what the value should be in a formal theory. And there's some new concepts. So let me start with the meta theory. And this is the one you're sitting in the house and let your brain runs. Try to look at the object over there. Try to think what this object really is. So where environment I'm working on. So that's the meta theory. So what's the basic question? What the motivation of such a project is? It's very simple. It's stimulated by a fundamental question. What is value intrinsically? Of course, you can say, well, no, economics has theory defined around value. The stable defined. Use the convex set, use the supply and the demand. They try to find a equilibrium, and that's the price. But that's the way you put them the definition externally. It's not intrinsically. Give you one example why the intrinsicity is so important. Remember that Professor S.S. Chen, his fundamental work is to make geometry into an intrinsic internal theory. Before that, it was external analysis. So you want to stand a theory by itself, not in terms of something else. Like you prove the theorem, you draw a picture on the blackboard, you see that's like this, that's why it works. But it's not really a proof. It's an illustration. So that's why we try to figure out what should be intrinsically. It's a very simple question. Or simply to satisfy a personal curiosity. So what a formal first order theory to interpret the theory of economics would look like. So that's the really curiosity. Remember that Professor Dean last time gave an answer to what's the motivation for you to consistently doing the research in so many years. He gave the answer as curiosity. So we need curiosity, we need intuition, but we have to persuade consistently. So that's the question driven me over so many years, try to understand what this object is. It's really like a very relaxed situation. You sit in the room, you look outside the object reality, you try to understand using whatever possible to build up a model. So that's what I'm doing. So these are the basic questions, motivated me for so many years. And every time I come back to the question, I feel excited. So that's the question that I have been working on. So therefore, given there's so many young talented brains in the audience, here I extend my invitation to you. I start to set up the framework. I invite you to join me to work on it. It's valuable. So the central ideas of an answer. There are so many answers, but there will be a canonical one. We try to search for a canonical answer. And the nature does not provide us with what we need. Okay, the nature will always provide something under alimentation. That's the reality. We need to find ways to make use of those very limited supply provided by the nature, like food, like clothes. So we have to, the nature does not provide us, but we have to find a way to make use of whatever provided by the nature. We don't create energy, that's the law of physics. But we create systems to transform energy, to make it available. We create systems or discover more efficient strategies to solve problems, to save time, to make more time available. We need to make time available to us. Time is uniformly skipped away. Doesn't matter who you are. The time is uniformly flying away. But we have to find a way uniformly try to improve our strategy, how to manage our time, to make use of it, make it available. Because only available time that we are working. We don't create energy, but we create useful intelligence. We think intelligently to find ways to transform energy, to make it available to do useful work. The availability is one of the key concepts. We think intelligently to find ways to save time. Again, we need to save time. Don't waste it. Such ways are then materialized, realized to serve our needs. There must be something objectively to be measured before any measurement attempts to be made by human beings. So that's in some sense, that's my philosophy, my standing. We measure objective objects. It's not just by thinking arbitrarily. So that's always an objective word there. So the intended universe of this investigation is the following. So the reality, so there's a meta term called reality. That's really the reality, whatever intuitive interpretation you have is there. It's represented by the universal objects of study. So you have to find a way to model those objects in reality. That's one of the objectives we have to achieve. So the universal objects of study is an abstraction of the reality. We must make sure our models, like any mathematical models, like for example, the recent discovery of Calabi-Yau manifolds, they reflect reality. That's very important. We reflect reality. And then, every human individual, so now I'm trying to explain to you what I would like to model myself, for example, being a human being. Remember, this economic theory interpretation is slightly different. Every individual is a part of the universe, the objects there. We are there. Economics is an activity. We are there. So, we are active triplet system. In some sense, we have a nourishment, digestion, we have to eat. For example, you go to lunch, you would need to share the coupon to gather food. Information processing. Every time we think of something, we are doing information processing. You are thinking, whatever, as long as you open your eyes, doing thinking, whatever you think, you are doing something, process information. And material realizing. That's by our hands. Using tools, we try to materialize, make things, like for make chairs, make tables, make the screen, make this computer particularly. So we have to realize the thing we can design to make it work. The active triplet system consists of three interrelated subsystems. One brainy information system. So many young talented brains are here. You have a very strong brain system. One manual realization operation system, the hands, the body, where physical work got to be done. And one internal biological information and energy system. That's for you to survive, for you to be able to think when you get up. So that's how I would like to understand myself as a human being, as a part of the economic activities. Each human individual system is powered completely and independently by own internal biological energy system. Namely, you have to eat food by yourself, not by any machine to inject fuel, at least now. We have to work everything out by ourselves. So that's the assumption. So each of us, each human life actively consists of three parts. Therefore, we have one biological. The biological activity is fundamentally responsible for own biological energy supply and for own existence. You eat, you digest. One, intellectual. Intellectual activity is responsible to provide answers to what to do, why to do, and how to do. Think, corresponding to the work. And that's what I call intellection, work. Think, information process. And then, of course, work. So basically, to understand this interpretation of economic activities, the key words are availability, think, work. Physical theory gives us a definition of what work is. But now we have defined what things are to make up the whole economic activities. For example, this computer system is designed by human beings based on Turing machine and the von Neumann architecture of computers. These are all intelligence results. Without this mathematical modeling, without have this von Neumann architecture, of course, without our understanding physically what the transistors are, how to define by the Boolean logical system to design this logical circuit, there will be no computer. You can tell why currently our society advanced so tremendously, because the real high-level intelligence contributed to it. So that's how I would like to understand our economic advancement or economic activities. How would I understand what values are? So in this universe, the fundamental motivation to human individuals is to solve the problem of lack of availability, because we don't have it. We have to find out. In the ancient time, people searching around to find some wild foods. But now we got much better availability now. Because of what? Because intellectual advancement, we have everything within reach. You give a call, someone delivers things to you. You know, it's a very simple thing, but you really think about it harder, there's a very, very deep reason behind it. And we have to find out why. So in order to achieve that end, human individuals need to know what to do, what to be made use of, what to do, and how to do. Human individuals need to get it done in the sense of materialization or realization. And this is another term of economic theory. And this way, human intelligence potentials and the physical body energy plays a role. Physical theory, physics and chemistry give us what our physical body potentials are. But now we have to give a definition what our intelligence potentials are. This audience, this is young talented people, the brain you have defines your own possible intelligence potential. By learning, by thinking, you increase the potential by yourself. Nobody else can help you but yourself. It's completely up to human individuals to observe and understand the nature system, the nature formations, the nature of information, and the forms of energy. Now there are 4 terms. Systems, naturally. Formations, naturally. Information, naturally, is not our abstracting or communicable information. It's built in within the natural things provided by the nature. So the forms of energy, as well as natural processes. We observe many, many processes. Even the rain is a process of nature. So that the ways of transforming energy scattered in nature into available energy, again, availability, and the ways of encoding manual information into communicable natural information would be found and satisfy the needs of supporting of life. Of course, the basic information that we can tell is the light or the photon. Basic ones. So observing and understanding are human active processes to gain information. So basic human processes to translate natural information into manual information. That's the one we write into characters, we can draw pictures, we can talk to each other in our own language, either English or Chinese, or in some other languages. That's what I call the manual information. but there's something behind where the sources are just from the nature. For example, now we know every biological object has its DNA. That's the natural information. Of course, we see that DNA is a form that we understand from the nature part of it. We say, oh, that's what we call the DNA. But nature doesn't call it, has a different name. We don't know. But we have figured out. So ways of transforming natural energy into available energy, detecting and interpreting communicable natural information, and encoding manual information into communicable natural information, a human active process carried out by human systems. And the computer is a system. Our cell phone is a system. And the communication, there's a very complicated communication system over there, which are all designed and realized and implemented by human individuals. They're all human products. And that's apparently, so all these designs and implementations are a result of human thinking and working. So I'm emphasizing the think and the work are the main things we have to pay attention to if we try to understand what economical theories of values are. All this take human efforts, another term, since the unavoidable intrinsic complexities. Now here's the real challenge the economical theory comes in, complexities associated to every human acting process. Every process has complexity. Of course, for those who are studying computer science, you know there's an algorithm, there's a complexity, a time complexity, and a space complexity, and etc., etc. But those are part of it. It's not what we are really thinking, but we are thinking something more broadly. Basically, in order to take those real challenges, human individuals need to think, to increase own intelligence potentials, what they call intellect, and to work to develop own systems, own processes, own formations. That's the end products. And the socialization, which means we have a communication, cooperation, interaction, education, organization, division, and integration, evaluation, as well as distribution. There are many terms. They are all familiar in the economical theory. But we have to give a way to define them in a mathematical way. So all the developments represent the challenge, the change of human thinking momentum and the working momentum. So to another two terms come in, thinking momentum and working momentum. In physics theory, everybody knows what a momentum in the moving particle is, how to that's defined. But we have to define in the corresponding way what our thinking momentums are, how the momentums are changed. So all the changes of these momentums are a result of information effects and or intelligence effects. That's a real core term. So all is necessary for own existence for each human individual. Think is necessary for overcoming own limit of capability in working of human individuals. Again, these are the metaphysical assumptions. With respect to a specific working capability limitation problem, a successful thinking provides an abstract solution, a way to overcome the limit. And a successful working following the way provided a realistic solution. Again, these are the metaphysical terms. But we have to find a way to embed the ideas into our formal system. What a tractable working capability limitation problem is essentially due to the lack of availability. Another repetition of availability. So a thinking is then to find a way to make up such an availability by designing and performing an appropriate transformation process. So that's how we make it available. Again, in the universe of intended investigation, so the dynamics of thinking process are information effects. This is where you can change your thinking momentum, what I call the information effects. The dynamic of working process are the energy effects, and that's what we call the force. Remember, you push something forward, that's a physical force. That's what I call the energy effects. Every real achievement of human individuals is the result of joint efforts of both intellection and operation. Two of them. The result of both think and work. Physically, we know, in physical theory, we know how to define work. Now it's our turn to define what think are. If formation effects acting on intellection, complexity space, give rise think. Energy effects acting on operation, complexity space, giving rise work. So that's how we reinterpret what the physical theory gives us, what other force really is doing. Achievements of a manual process is the product of think and the work of that process. So that's the metaphysical way to formalize, to represent, to say something, we're going to formalize it. Now, let me tell you what are the basic concepts I'm trying to formalize in the objective theory, in the objective language. Previously, I explained to you what are the metaphysical language in terms of English, or the way just like a philosophy statement. Now we have to find out how we are going to really represent the basic concept in the formal way. That's what the logic is doing. Remember at the beginning I said, every formal theory stands over a meta theory. So the meta theory translated the idea, our understanding of the real world, into something we intend to represent in the formal theory. And then you really work out a formal theory, like mathematics. So the basic concepts are the following. We divide into categories. The first, of course, time-space. Time-space systems and processes, formation, energy or substances, information, availability, complexity. And each of them has their own theory or sub-theory. We have to formalize it. And the effects. And these are the key to define what we mean by intrinsically the value of economics really is. Achievement. So the last two are the core, but the previous 8 are the really basic things, particularly complexity, availability. And then 3 main categories of the systems. Here we have the natural systems. Okay, everything here we have the nature, we live on the earth is part of the natural systems. The active information systems and artificial systems. Artificial systems like computers and the cell phone and etc. and etc. If in the way you take notes, that you are like me here, human being is a part of the artificial systems, part of the natural systems, because we were born, have a brain, we are able to eat, we are able to walk. This is from the nature. And then the 3 main categories of processes. So we have make a distinction what the natural processes are, and what the thinking and the working processes are, and the communication, transportation, computation, production processes. So these are the different systems. There are 3 main categories of information. One, of course, is natural structural information, and the natural communicable information, and the artificial manual information. The human products on information are the 3rd category. 3 main categories of formations, natural formations, and like for example, you take away something out of the tree, maybe it's eatable, it's a natural formation. Energetic formations, a source of energies. artificial formations, like the end product that we're using. And the four main categories of current and global complexities. Complexities are structural complexities, procedure complexity, like operational complexities, communication complexities, computational complexity. What I mentioned, like gave an algorithm, you try to find out what's the time complexity, what's the space complexity, and etc. in time. Procedure complexities in current available energies. That's very important, economically speaking. Intellectual complexities. That's the one we try to define what the things are. We try to define what the intellectual effects push us forward. So what's the intellectual complexity? For example, Riemann hypothesis is one of the very complicated conjecture. It has been by so many brilliant mathematicians working on so many years, try to understand what Riemann hypothesis really is. The high complexity. You can think of intuitively because take so many people, take so many efforts to understand it. And of course, there are many other mathematical conjectures to be solved. You can look back. When they solve it, you find the accumulation of the process is so complicated. Give you one example. The Carabi conjecture solved by Professor Yao. It's a long way. It's very complicated. Take the whole challenge. And the challenge is so high, people gave him really honorable recognition. That's appropriate. It's proportional. That's what I call the intellectual complexities. They're sliced up. When you solve some real mathematical exercise problem, you find something that's easy. And there's some others, oh, it takes a little harder to think about it. And there's some other one, I couldn't do it within today. I have to think about it, come back later, maybe a week. Because of what? Because of objective complexity over there. So that's what I call intellectual complexity, and that's really the key. So natural systems, including whatever you can think of the natural organization, including those embedded organizing material formation and the natural structure information. And this is something I must pay attention to and explain to you. I pay attention to on the real objects, the natural information inside. We call something, we call a DNA. But there's something inside first before we find out, we give a name of it. So natural processes, the environments, inputs, outputs, including material formation and energy, time-dependent procedures. So natural formation is material products, energetic storage, is resulting in some natural processes. Communicable natural information, so light waves, sound waves, resulted in some natural processes. Primarily information resources detectable, encodable, and transmittable by human individuals. So these are the what I call natural informations. But it's not easy to find out. For example, so far, for example, the quantum stage try to understand how the real micro world, the information are embedded and how it actually with energy interplay. Active information systems like the one that we are, a human being, and also partly the computer systems, working and thinking, understanding, designing, and implication, doing things and work. So that's in the universe, every individual at every time is inside. So it's like a very long, the time is like a river, and our human activity is like a huge board on it. Along the time road, we fly. So artificial systems include artificial information systems like computers and artificial formation systems, those designed and realized by active information production systems. So artificial or manual processes, production, working process, computation process, observing, measuring process, and thinking processes. Those carried out by active information production systems or by artificial systems, like by a robot. For instance, observation, separation, isolation, measurement, investigation, communication, determination, realization, and implementation. So these are all the TION are the processed by human or team of humans. Artificial or manual information, those realized by active information systems with or without application of artificial information systems. And artificial or manual formations, those resulted by active information systems with or without application of artificial formation systems. That's basically human products. End products. You want to differentiate which one is the system, and we can use to do something else. Or this is the end products. So functionality and availability. So these are the things at the end product we try to measure to define this functionality and its availability. Complexities. These are the corresponding system structure complexity and procedure complexities and intellectual complexities. So effects. The energy effects is well defined in physical theory, and the information effects are the one that we have figured out how to define. And the intelligence effects. So again, we have to figure out how to define in a formal way and consistently coherent with our intuition. System powers, including constructive powers and destructive powers. Human being can be very constructive and sometimes can be very destructive. So it's nature. So nature is constructive and also is very destructive. System capability. So the capability, for example, for ours, our brain capability is during the process we can increase or we can just waste our power. So achievement, and that's finally what we have achieved during by the end of the day. Of course, at the beginning of last Sunday, we see that we gave outstanding lifetime achievement award to a few brilliant mathematicians and physicians. They have done tremendous contribution and they been recognized as lifetime achievements. Of course, here we are considering every possible achievement, whether small or big, etc., etc. So these are the formal concepts that we have to formalize within the objective theory. Now, let me explain to you a little bit about the formal theory what we have. Again, I'm not going to get involved too much of the technicality. As I told you, since 1991, I've been working on it. The previous 10 years was trying to understand the things in a metaphysical way. And then, about 10 years later, I started to write down the formal part, or internal trying. There are many revisions. Like I think that one day, the professor has introduced the contribution to the mathematicians. He mentioned one thing. You will find a 99.9 possible way to make mistakes. Of course, we make mistakes. You have to revise what you are thinking, write it down. So the meta theory, I'll give you a very brief outline. So in the formal language, we employ the following symbols and accents. I'm not going to explain what they are, what it means. So we have the binary predicate equal t to represent the same time moment. And that's the equivalence relation on everything in the universe, which is a non-trivial equivalence relation. And we have a binary predicate to represent what I mean by before, which is discrete linear ordering of Cauchy space given by the equivalence relation. And we have something before, something later. And again, the basic fundamental metaphysical assumptions here for me, for some reason, time is not going to be continuous. Time is discrete. The timeline where we put a unary predicate to represent the time. And they divide the whole universe into slice into equivalence classes. Basically, we are really tell the things at this moment. Before, that was our memory. Future is something we have to figure out. The binary predicate passed off, try to record what should be in our memory, which is really to the past, to the present. So we have a axiom of time because we have to give a very simple way to answer time space. Space-time, by the way, the metaphysical theory I'm using that the time space is Einstein's major theory of time and space. That is really it's not this global one. It's not general relativity, okay? But this Minkowski space will be the one that we'll be using. But anyway, we can write down the first order theory, what these times are. Of course, that's about our understanding what I mean by before, what will be later, and the compatibility. This is about time. Okay, so time is given by this predicate, unary predicates. We try to span this. And then we have a historical relationship. And that's very important because currently, like for example, me today has come from me yesterday. But yesterday was something in my memory, or somebody saw me yesterday in his memory. But that's a mapping by nature. So that's something we have to represent. Again, in this theory in the universe, or in the intended universe, we have everybody, every human being is inside. Okay, you can find that's a name for each of us inside there. So that's how the historical relationship gives us the way. Now, why I said we built up the whole thing in terms of set theory? Why? Because the fundamental philosophical things to be pay attention to is why truth is invariant. What's the reason? Why the theory proved 100 years ago, we still accept as a truth. Why? So we have to answer this philosophical question here, and that's why the axioma set theory is there. Because we have, along the timeline, there's a universe of sets, and between each of slides, there's a natural isomorphism. Make sure every translation or every model you can represent in terms of abstract mathematical language, in terms of set theory, and that's invariant in time. So that's the way how we can have this. We have a uniform representation axiom, namely we can represent in the universe on the slide at the same time to an abstract concept of words. By the way, this one of the ideas was from Feng. Feng had this so-called third realm, and also that's good called the concepts realm. Okay, there's a realm of concepts which reflects the reality. Of course, the realm of concepts are the results of human efforts. So that's why I give another more concrete interpretation what a good realm of concepts. We add our contribution into this realm of concepts because there's a nature there. Doesn't matter we think it or not, they are there. Just like the moon is there, whether we close our eyes or open our eyes, it's there. On the other hand, we try to understand what they are and how it works. Why like that? So these are the answers we figured out. We put on the paper in a certain language, we all agree this represents something there. So that's the realm of concepts. And here I made a very simple assumption. Doesn't matter how complicated the objects are. We are able to represent in the uniform, simple language safely. Again, that's because I've studied set theory. So, here's the environmental set theory universe. How we can connect one slice of the theory into the other. So these are the axioms. And again, I'm not going to do much of the interpretation of this. That's why I call the environmental theory here. And then stability. And that's why our truth is environment, because we have the official stability there. So again, don't worry about what the technical terms are. And then we can define in this language the only binary predicate simple is this epsilon relation. So let S be a simple, we define the relativize the complexity. Okay, we can define this, how the things are, the relativization. Again, this is rather technical, but don't worry about it. And when the time comes, you know what I mean. So based on this, we have an axiom scheme of set theory. So everything I take as ZFC. And there's a standard set theory so far with axiom of choice. Z is German law, and F is Frankel. Of course, in this theory, it's not just this part of the ZFC stand for. I do apply Frege's rule for the first order logic in this very simple language epsilon relation. So again, this fundamental things is very interesting, challenging to work it out. I can tell you that my 3-volume books, down the calculation, the 3 volumes I call the meta foundation, meta theory of meta mathematics. These 3 volumes are going to be appeared by the end of the year. So these are the basic things to set up, make it work systematically, and that's how we can do the interpretation this way. So anyway, based on this, we can define what I mean by based on the invariant truth of the set theory. We give a definition precisely the invariance. So that's how it's defined. And then we can define this very interesting binary predicate F. Okay, so that's the F symbol. And this will help us to set up this isomorphism. Okay, so this is the really, as time goes on, yesterday's set theory and today's set theory and tomorrow's set theory, and they are in this universe are naturally isomorphic. And this F is the one. Okay, that's if an energy transformation from yesterday to today and to tomorrow, you can trace by this function. So that's how we define this isomorphism. And then based on this, we can define, after that we can prove the theorem, what we call the stability, and why stable, and why we can trust our understanding of yesterday. Because we need our trust on what we have done before we make further effort. And that's the reason. So based on this, we can define this. This is really like a very simple isomorphism closely under composition. And then that's important. Invariance of definable sets. Definability must play the role, because everything we write it down will be definable. Only those definable things we are interested. Of course, you see something you don't understand now, but don't worry about it. Time goes on. Will be someone smart enough find a way to define it. If eventually been defined, of course, there may be something never ever been definable, but that's a different story. So we are interested in those which are eventually or has been or currently or later on been definable. These are the objects we are considering because we are trying to define what value intrinsically is. Without definability, we cannot say much about it. So therefore, here are the hypotheses in a fundamental way to explain those concepts. And there are many hypotheses. There are so many that I feel a little uneasy. I wish somehow I can reduce the number of hypotheses, but they are there. So far, that's my understanding. And that's why I see there's an invitation here. I believe in the audience, so many young talented brains who has much power potential than me I have. So here's an invitation. This is something I'm interested in. I hope one day you will find it interesting. So we can work along or in different ways. But the question is still there. So here's a very simple linear model. Try to give a model because we need a model of the brain. I'm not going to give a complicated model. Okay? I have a model of the brain. Okay, at least it work so far. But here's a very simple version of it. So a linear model, the degree of concentration is the brain power increment coefficient. Concentration, degree. Okay, I mean, this is intuitive that everybody will agree. When you do something seriously, like doing the examination, you find out after the examination your face feel warm or even red because of what? You are concentrated doing something. There's a high degree of concentration there. And the output of thinking in intelligence is proportional to the value of the concentration degree times the intelligence power. Each of us has our own intelligence power. The thinking power in brain energy expenditure. Okay, we translate our physical energy into the brain energy to increase our thinking ability. So the complexity of the intelligence is then the thinking power times the full concentrated total thinking time period. And the brain capability does need. What's the capability? It needs as a minimum high power and as minimum length of lasting that power, the product of them. The brain energy power times the maximum problem motivated continuous excitatory period is proportional to the intelligence potential, the largest capability of the brain. But it can be improved by working along the way. So being a student, you haven't reached the highest capability yet of your brain. But by thinking along the way, over years, you will have a much better improvement. And we all have the same feeling. Why I spent so much time on this problem yesterday? Look, this is so simple. Because of what? Because your intelligence ability has been increased by the time you spent yesterday constantly thinking. It becomes powerful today. So that's the basic linear model. So about the functionality and availability, here are the axioms. Humans prefer higher functionality than lower functionality when choices are available. And that's typically true. Law of irreversibility. When the energy transformation system has transformed certain amount of energy, but this is physical law. I don't have to say much about it. Okay, energy cannot be reversed. We gotta use it, and that's it. Cannot be reversed. And the law of non-recoverability. And this again, that's a physics law. So I just skip it because I don't have much time left. And then, law of disinformation. When information is gone, and it's completely destroyed. Okay, that's why, for example, there's a code information, and you burn it, and that's it. Nobody else can recover it. And then, law of order in usage. And this again, like our personal or a daily life intuition, and I call it action. An object must exist, be available in time and in place before it can be used in the specific time and place. And that's like a trivial things. But if you want to define things, you have to write it down the obvious things. So we can prove a theorem called the law of future inaccessibility. Anything you have tomorrow, you cannot have it today. That's the basic idea. And law of uniqueness of energy transforming. That's again trivial, but you have to set down the system to give a proof. Literally, it's internal proof. It's not by draw a picture or something, use some external ones. So on complexity, we have the axiom is there's no energy transforming system with an unlimited storage of infinite energy. So every system has a limited internal storage. You would agree because you have to eat every day. There's low acting systems with unlimited memory of information. Again, our brain only has limited cells. You can't have infinite, because simply we don't want to have a Superman in this universe. That's the basic assumption. So each job or task demands certain intelligence and certain think and certain work. That's the complexity decided. So we just put it into the table and we need them. So law of inertia. If the slow phase, which that's really like the phase is the corresponding like a force. That's what I previously called information effects. If the slow phase act down, then there's no change in one's intelligence. So you have to find the information effect on it. So here's the axiom. You put it in simple, and that's what I call the law of information effects. Again, don't worry about what simple means are, because I needed them to define and how we can change the inertia of active momentum. So that's what we call the axiom of human inertia of active momentum. And you got two things, intelligently and this working things. All right, so again, this is another axiom. I think that we just passed by fast. Another axioms. And again, that's how the complexity measurement are related by this fundamental relation. So don't worry about what it means. And basically, what I want to use that by the joint efforts, you can do that actually in theory, which can be communicated. And then let me draw the conclusion. So nature does not provide us everything, but only limited something to human. Human brain, we need intelligence to think and work to transfer those limited something to available. Intelligence to make use of external energy and supply a speeding up a realistic production system. The limitation and the loss of nature dictated the complexity of any realistic manual production process. So operational complexity, which I use this earlier for, is a physical challenge demanded by energy. And intelligence complexity is this simple. And then we have a realistic achievement of any realistic process is the product of intellectual efforts and energy efforts involved in the process. Availability and functionality achieved are proportional to the product of these two, potential and energy. The complexity of availability and the functionality achieved is the sum of the intellectual complexity and operational complexity. So based on this, we can define what I mean by intrinsic value. So the value of every manual constructed object is determined by the following equation. So theta is the total thing done accumulatively, and W is the total work done accumulatively. Of course, we have to eventually find out whether two equations can be checkable, satisfied, or coherent with our intuition. But that's the market value of a human product is just an intuitive approximation of the true measurement of its intrinsic value. This, of course, is my interpretation. Thank you.
Now is the section part. Does anybody have any questions?
Thank you for the talk. I have two questions. The first is I'm wondering whether this work maybe in the future can be affected to the research, for example, of the economics or the management or something.
Very good question that I would hope so, but I don't know. That's really whether the theory is coherent, is consistent, and is applicable. It's up to each people in the field how to look at the one. That I don't know.
All right. And the second question, in a lecture, you mentioned some methods uh, to express the so-called value or something. I'm wondering because maybe in the real life, some values can be divided into so many various things. For example, some personal relationships or some resources. And yes, so I'm wondering how can this maybe very difficult to be expressed to be done in the theory.
Thank you. That's a very good question. Again, I'm not claiming that we have to consider all the possible what we call values. Only for example, you mentioned this one, personal relationship. This is rather subjective value. And again, this we are talking about something objective, which can be defined, can be measured. Currently, for example, that people now doing that, what's the so-called what's the cost? Okay, and that cost including the salary and the material and the factories and the houses and etc. and etc. And then you plus shipment and etc. and etc. You put all four price together, and then you add some really arbitrary or individual decide what's the interest. Okay, you gain from by selling the product, you gain some money. Okay, for example, why the Microsoft this Windows system was that much money? The price is defined by whoever the supplier is. Okay, what should be the value? That's the challenge. That's the question. So that's something we try to figure out. So we're not considering all the possible so-called values. That's too complicated. And particularly we got a society involved, we got a cultural background involved. That's more complicated than what I am thinking now. Thank you.
Thank you.
Does anybody have questions? Any else? If there is no questions, we thank the speaker again.